and this here you see the examples of all those patterns before. So this is actually this semantic model of this airline operations. And as before, so first, and you see all different patterns. So for example, this is P1. P1 is basic. So what is the example of P1? So we have this object class flights, and we have flight types, right? And for a flight type, you remember I told you that, for example, what is a flight type? For example, a flight from Newark to Washington, D.C. that departs at 1 p.m., right? That's the type of the flight. Now here, you see, in both cases, you see the departure time attributes. Okay? But the attribute at the policy level tells you what the departure time is supposed to be, right? So this is what we want. And the attribute at the operational level tells you what the actual departure time was, right? And when you subtract the former from the latter, you will calculate the delay, right? So for every record in the flight table which is associated with that particular flight type, you can do this calculation. And you can, for example, can obtain the result that the flight that departs from Newark to Washington, D.C. at 1 p.m. on average is 40 minutes late, or something like that. Okay? So it's good to analyze your systems, right? Now you also have a mirror pattern here. Okay? So what does this mirror pattern do? So it is actually, so now you have this mirror means what? So there are two classes at the operational level, right? In this case it's flight and plane. This is the table where the actual planes are listed. There is a flight type, there is a plane type, and there is an association here. In this case, it happens to be an association class. So you see it's called target. So it describes what our objective is, so what we would want from these flights. And here, this one would say that, say, for a flight type of this, using a plane type of this, right? So those are the allowed, what is listed here are the allowed plane types. And for each plane type, which is listed here for this flight type, we will specify an attribute, which is the targeted fuel consumption. It makes sense. Why? Because fuel consumption depends on the plane type, right? 757s would have a certain level of fuel consumption. 767s will have a different level of fuel consumption. But the fuel consumption also depends on the route that you're flying. It depends on the flight type. It depends where you fly, you know, takeoff, landing, what time of the day you fly, what are prevailing winds you fly, right? What, depending on the flight type, you can fly lower or higher. So all that affects fuel consumption. So therefore, it makes sense to specify this targeted fuel consumption here at this level, because it depends on both. Okay, for each flight type and for each plane type, you can have a specific fuel consumption, right? So it does make sense to specify this fuel consumption attribute here. And this is what our target is. This is what we want it to be. In the same way as the attribute departure type in the object class itself will tell us what we want. Now, what is different here is that the actual fuel consumption, even though that the targeted fuel consumption is an attribute of the association of the relationship. So it will be an attribute in the relationship table. The actual fuel consumption is the attribute of a particular flight. Why is that? Well, it is actually also an attribute of a flight and the plane associated to that flight. But it's all in the same, because if you're talking about a flight and the plane, an actual flight and an actual plane, there is a one-to-one relationship there, right? So it's, if you know, I'm sorry, it's withdrawn. The association between the flight and the plane, it's a one-to-many. I'm sorry. No. It is one on the plane side, many on the flight side. So the association here is one on the plane side, okay, and many on the flight side. Why? Because for every flight, there is only one plane associated to it. But for every plane, there can be multiple flights associated to it. So it is one to many. So what does it mean? It means that if you know the flight, the plane is defined. The plane is fixed. As a matter of fact, in this case, if you probably remember your basic database theory, you will remember that you don't need a special association table there. So the way this will be implemented is by adding the primary key of the planes as the foreign key to the flight table. Okay? So there will be no separate association table here. So there will be a foreign key in the flight table which identifies the plane. So therefore, the actual achieved fuel consumption has to be an attribute of the flight. Okay, so it may look a little bit strange that the stated target, the policy, is at the association level, right? But here, it is at the flight level, right? But it is also a reflection of the fact that this thing actually has to be many to many, right? Usually, it cannot be one to many. While this thing has to be one to many. It has to be one on the plane side, and it has to be many on the flight side. Questions?
I was just trying to make sense of that one-to-many relationship.
Okay.
So one plane can have many flights, but many flights can...
No. It's not. It's always you start from the opposite side. So if it is one on the plane side, you say for every flight, there has to be one and only one plane associated to it. So if you're talking about the many part, which is on the flight side, you start with a plane. And you say that for a plane, typically there will be multiple flights that are associated to it, because if those are different actual flights, they can use the same plane. Okay, and the way it is implemented, again, if you recall your basic database stuff, so you will take the primary key from planes and add it as a foreign key to the flight table. Okay? Okay, so what else do we do here? So we have this compromise relationship, right, which is P3. So this is about cancellations, right? So, and this relationship, again, this is an association class relationship, right? It defines for each root type what are the allowed cancellation types, okay? And for different cancellation types, there will be different perks, right? So if the cancellation is, say, mechanical in nature, right, then you have to provide room and board, for example, for international passengers, right? But if it is a domestic flight, you probably don't have to, right? Or if it is weather related, then even for international passengers, you don't have to provide room and board, right? You're covered because you don't, you're not responsible for, as they say, acts of God. Okay? So it is defined at this level. It is defined at this level. So this is where the relationship is described. But the way it is established is really a compromise type. Why? Because we do not have separate cancellation events. It doesn't make any sense. Why? Why doesn't it make sense to have any separate cancellation events? Well, because if you think about it, what is a cancellation event? A cancellation event can be viewed as a status of a flight, right? And flight is already an event. So from that point of view, it is just a feature of a flight, right? So that's actually a somewhat similar story to what we had before. The only difference is, because of this, it's a compromise pattern. So here, it's again the same story. So the relationship between flights, the cancellation types, will be many to one. It will be many on the flight side, and it will be one on the cancellation type. Right? Because when a cancellation is announced, it's going to be just over one type. And you cannot cancel the same flight twice. Right? It's either cancelled or not. So therefore, again, in a way, it's going to be just in this table, you will record the cancellation type code, which is going to be the identifier of the cancellation type. Right? This is going to be. And then the perks can be read from that table. Right? So basically the way it works, you record this as a cancellation type. You know what kind of a route type it is. You just go down the go up the policy level, and then you find the appropriate record in this association table, and from the perk attributes, you read what the passengers will get in this cancellation type. So this is how you check the policy and see how it is applied. Again, the policy enforcement mechanism is completely generic. So everything is stated through the records in these tables. Okay? So we can keep going on. So the same thing, for example, the hybrid pattern, right? With the service operators, right? So in this case, what's the difference between compromise and hybrid? So in the case of compromise, we had a type for which it didn't make sense actually to create separate operational level class, right? Here it's the opposite. So we have an operational level class for which it doesn't make any sense to typify it. When does this happen? Like here. This usually happens, then an object class like this has very few instances. Okay? So for example, say you're running a hospital, right? And you want to service complicated medical equipment there, right? In the old days, there were multiple service companies and many different categories and all that stuff. It probably would have made sense somehow to categorize them. Now these days, it's pretty much the three big manufacturers of all those CAT scans. It's really either General Electric, or Siemens, or Philips. Okay, and that's it. So they run the show, more or less. I don't think that you have much of a choice. So if you want, like here, so there is a very limited number of all those service operators. Right? And So there is no reason to do that. So basically, like here, the hybrid pattern is given by this association, right? So what does it mean? So in this case, so this is our hybrid pattern, right? The association that we are talking about is here. Don't be confused that it is shown differently. It is shown differently because of the layout of this slide. But this fleet is a grouping of plane. Fleet is not a grouping of the service operators. So basically, this relationship corresponds to this on the pattern. Okay? So here, this is this typification of grouping relationship. Okay? And this is the policy. So on this slide, this is our, in this case, this is a grouping relationship. This is not a typification relationship, this is a grouping relationship. And this is our policy. So what is our policy? Our policy is that different fleets, so service operators are assigned by fleet. Okay? So a fleet has a contract with a particular service operators, and only service operators can service those planes. So when you here record the identity of the service operator for a particular plane in this association, right? It has to be in agreement with this policy, right? That service operator has to have a contract to service the fleet this plane belongs to. By the way, I'm moving really slowly. And some of you actually are not paying attention at all. I understand that for the accounting students it may sound a little bit strange. For the system students, this is probably a little bit more interesting. But again, this is not simple stuff, guys. This is, if you think about it, you are talking about accounting system. This is how policies are described in the accounting systems. And again, what is the enforcement mechanism? Again, generic rule. So you check the identity, you check what fleet the plane belongs to. You check if there is this contract for that fleet with that service operator, and then you determine if this assignment can be made or if this is a legitimate assignment, whether a particular plane can be serviced by a particular operator. Yes?
Usually the system, is this checked after the fact, or?
It depends. So Ahmed is asking whether this control can be implemented as a preventive control or whether it has to be implemented as a detective and corrective control. It's your choice. The tendency in modern systems is to implement preventive controls.
So you can't even try.
Huh?
You can't even add.
Yeah. So if it were up to me, but keep in mind that if you have preventive controls, then the issue may arise that that you may need a management override. That you have to service the plane and there is no operator available, so that may be a problem if you implement it, because you may end up in a situation that, as I often describe to my undergraduate students, that you want to put something into your system and you think that you should be able to do that, but the system tells you that you can't. Okay? So if you implement it as a preventive control, it means that the code is there to reject a record which is not in compliance with that policy. And then whether you want it or not, the computer will not let you, right? Hopefully this is exactly what you want. In many cases, if you want to have a tightly controlled enterprise, this is exactly what you want, right? You want preventive controls. But that's a separate decision. So how you enforce the policy is a separate decision.
Do we look for these when we audit their controls? Do we look for these?
Well, when you do audit, it's basically the same thing as a detective thing.
I mean, are they? No, we'll see if the control is in place or not. Is it preventative or not? Do we look for this stuff?
Of course. Yes, absolutely. So when you look at control system, yes, of course, you look at what kind of controls. And again, it's the same thing. The strongest controls are preventative controls. So if you have preventative controls and you verify that they're functioning properly, that's the best you can have. Yes?
So the control that you're talking about, would that fall more under like entity level controls?
Or you're talking about the control categories?
Yeah, I'm just trying to think like activity controls versus like policy controls.
No, it's no. In this case, this is an enterprise policy, right? So it's not a particular IT control. So if you're thinking in those terms, this is a general enterprise control. This is general accounting policy. If you are if you think about general controls, you remember there are general controls, there are application controls. So one of the types of general controls is compliance with the applicable policies and procedures. Okay? So this is one of them. Yes?
Yes, so we're not looking for specific observations, we're just looking if the policies are well translated.
Well, but then every observation that you have must comply.
But this is another stage, right?
No, this is exactly the stage. No, when you're looking, so if you have, say, a particular control, you have a particular corporate policy in place. So in this case, the policy states that your planes have to be serviced by approved operators. Okay? The planes have to be serviced only by the approved operators. So that's your corporate policy. So when you do your internal audit may do the so-called compliance audit. So this is exactly what they're going to check. They will look at all the observations to make sure that each and every one of them is in compliance with the state.
Initially, don't you do like just is the policy well, is it translated well into the system or not? Is something around this?
Of course you do, but so those controls can be implemented using different means. So basically, the content of this paper is to say that these are the right means to implement those controls. So that these controls are supposed to be implemented like this. Because alternatively, you can write a piece of code where all these conditions will be just written in the code. You can write exactly the same policy in the code, right, of your system. And then the observed results should be exactly the same if the code is correct. The problem is that the code is not maintainable. The code is not comprehensible, right? So you cannot really look at it and see what the policy is. While if you declare it, use declarative means like here, and a generic enforcement mechanism, which is the same for all different types of policies, then it becomes very easy to maintain, very easy to understand. So this is basically the crux of the matter. This is what this paper is all about. How are you supposed actually to implement particular policies? So I can state you this policy, but how I can put it into the system is entirely up to me. I can have a completely manual control. I don't put anything in there, I don't put anything in the code. I have a guy who makes a decision. So if you want to service your plane, you come to that guy and he will tell you who can service the plane or who cannot service the plane, right? And you hope that he will actually make those calls according to the policy. That's going to be a manual control. If you happen to have a very good guy who never gets sick, who never goes on vacation, right, who never gets distracted, you may be perfectly fine. All your observations will be in compliance with the policy. Is it the best way to do that? I would argue that no.
Then you should test it if you know the controls.
Anyway, so I can keep going with whatever remaining ones are, but let's move on. Yeah, that's another one. This is very similar to the hybrid pattern we just discussed. Okay, so this talks about this heuristic nature of patterns. So So it's like with the service operators, right? So what are we talking about? So pilots are usually qualified to fly certain types of planes. Okay? So you may be perfectly qualified to fly 737, right? It doesn't mean that you can fly 747, right? So those are separate qualifications. So where do you stay? This should be your policy, where you record who is qualified to fly what. Now here, we really do it at the individual pilot level. So there is no reason to say that we could have done it differently. We could have assigned pilot categories and then check that the relationship would be between plane types and those qualification categories of pilots. So we don't do that. We don't create that object class at the policy level. So we directly record policies as a relationship between plane type and pilot, right? The only difference between this and the hybrid that we had before, so hybrid, right? So you see here the relationship, if it were a real hybrid, then the relationship should have been between a pilot and the plane, a particular plane. So what is a plane? It's a, say, 737 with a particular identification number, right? But the thing of the matter is that pilots are not really assigned to fly that particular plane. Pilots are assigned to fly a flight, okay? And it is a plane that is assigned to the flight, right? So it is basically a hybrid pattern, but there is this thing, this is intermediary. So basically here, we have the policy stated here, we have an assignment here, we have another assignment here, right? So we go from here to here through the assignments, and then we check that if that plane is of the type for which the pilot is qualified. Okay? So in a way, you can think of this pattern as the extension of the hybrid pattern by transitivity. Okay? So there is a transitivity from here to here and here to there. So by transitivity we infer that there was an assignment of a pilot to fly that particular plane for this flight. Okay? So it's an indirect relationship. So it goes here by transitivity, and then because we know what type that particular plane is, and we know for what types the pilot is qualified, so then we can check if we are in compliance. That we use only qualified pilots for our flights, to fly particular planes. Now, you can realize that the transitivity chain can be as long as you wish. So in this case, the transitivity chain has the length of 2, right? But you can have a transitivity chain a length of 3, a length of 4, whatever. So it doesn't matter. So we don't list all those patterns as separate patterns. So in technical terms, this is a different pattern. So this is not a hybrid, as described there. But it is essentially the same thing. It is this extension of a hybrid by transitivity. Questions? So just keep in mind that it's not exhaustive. So that list that we saw is not exhaustive. There are other things, but they capture some very, very essential things. Okay, great. So all that was fairly generic. Now let us talk about a specific application of all this to the REA information systems, right? So how do we apply this, and what are the different specific things that we do? And why we do that? So, well, first of all, it's a very concise way to represent the policies, right? And it doesn't really matter what the current records are. So the current instances are the current instances. The policies, the way they're expressed, are generic policies, right? And they will stay there. And how we do that, of course, depends on a particular system. In the same way as the REA model is still provides you just this basic guidance, general guidance. How you follow that guidance is up to you. Okay? So what kind of categories we use for resources, events, and agents, right? And as they say, so resources are typically categorized based on their technical specifications. For example, we can have different categories of fuel, right? So we can have storage where we keep different fuels, and for each particular storage it can be, say, different categories. For example, by the octane rating, right? 87, 93, whatever. Now, events are often categorized by their mode of execution. So, for example, if we are talking about sales, so we have different sales events. So there may be different categories, like distributor sales, where we go through a distributor, or internet sales, which will be direct sales to the end customer, and other things. Agents, internal agents, are classified based on their roles or based on their skills. For example, we can have a group which are salespeople, right? We can have another group which are inventory people, right? We can have yet another group which are accounts receivable people. Those are different categories of agents. Or also it can be based on skills. External agents are often categorized by their qualification. For example, if you're dealing with customers, you can categorize them by their credit worthiness, right? Right? Or vendors can be categorized by their quality. Okay, so how do we group them? So when we create policy definitions for resource collections, you remember that when we do groupings, you remember that grouping entities typically had a lot of derived attributes. Okay, so that was a difference between typifications. Typifications usually didn't have any derived attributes, right? Because they were attributes describing general categories, right? Which would apply to every member separately. When we're talking about groupings, they would have attributes that would describe that group as a whole, like the number of members in the group, right? So the policies can be based on both. So, for example, we define a policy for a group. We can say that you remember that we could base grouping on categorization. So we can say that I don't know, our rental fleet will consist entirely of mid-size sedans, right? That's a way to define a policy. Or so we can say that we can have a minimum and maximum number of members in the resource collection. So, for example, that our fleet should have at least 10 cars, right? Because that's the minimum that we can live with, but no more than 20 cars, right? Because we don't want to splurge on it. Again, that's another policy. When we're dealing with events, it is very specific. It's very common to use timing. You know that, so for example, sales are, say, categorized by the quarter. Right? Whether they happen in the first quarter, in the second quarter, in the third quarter, and all that stuff. Or it can be put a restriction on the number of members in the event collection. That so you buy, I don't know, you go to a station for washing your car, right? And you buy a ticket for 10 washes, right? So this is a typical thing. So this is a grouping of events of car washes. And there is a restriction on how many events you have in this group, no more than 10, right? So after you wash your car for the 10th time, the system will not allow them to record another event in this group. That thing is completely used up. Okay. So for the agents, it's going to be similar to the resources. We can define policies in the same way. Okay, so let us look at some examples. So here we'll see a number of examples, how this is all applied to the REA systems. So here we are dealing with the basic pattern, right? So there is this operational level, right? At the operational level we'll have a resource. At the policy level we'll have a resource type. So the policy mechanism is attribute. It means that there will be an attribute at the policy level, right? And that policy level will specify something about this operational level. Now, as you recall, the actual we distinguish between three different actual policies: knowledge-intensive descriptions, validation rules, and target descriptions. And knowledge-intensive description, this is something that characterizes the other thing to which the policy is applied, right? So just it is applied directly by the inference. Validation rules actually state the constraint that has to be enforced. And target descriptions state something which is desirable. So it is not going to be necessarily inherited. It is not going to be necessarily, it's not going to be necessarily enforced. But this is something that we would want to achieve. It may be either compliance with the standard, where we can have some deviations, or it can be a target on our operations or whatever. So here, you see all three types. So the mechanism, so pay attention to this. The mechanism is exactly the same. It's the attributes at the policy level that we use. The pattern is exactly the same. It's the basic pattern. It is basically a typification between the operational object and the policy level object, right? But all three different types of policies are expressed here. So we have a knowledge-intensive description, we have a validation rule, and we have a target description. So what is a knowledge-intensive description? Well, the product type specifies the price, right? So we are selling products at a fixed price. So every product of this type has to be sold at this price. So there is no room for negotiations. There are no quantity discounts, my way or highway. So that's the product, that's the price, take it or leave it. Okay? That's basically how, in my experience, markets operate in Japan. So when I went to Japan, the first thing that I learned that in most cases there is no haggling. So it's just the opposite of the bazaar. And if you try that, they will get offended and they will not sell you anything. So that's the product, that's the price. Take it or leave it. So that's why you see this is the derived attribute. So if you don't really even have to put it there. You know, the derived attributes really, in many cases, you don't want. I mean, it's like a materialization conclusion. If you put it there, it must be for a reason. Okay? But it's just derived. every product of this type will be sold at this price. Okay? Now, we can also specify valid colors in the description of that particular product type. And then a particular color of the product must be one of the valid colors. So this is an example of the validation rule. Okay? So this is not a derived attribute, because there may be a number of different colors which are allowed. So we have to describe a color for the product. But our generic enforcement mechanism will make sure that we can only put the color which is listed here. Okay? So this is an example of the validation rule. And finally, we want to achieve a certain target weight of the product, but we know that we don't always control it completely. So when we make this product, the weight may vary. Okay? So therefore, that target weight is an example of a target description. So this is something which is desirable, that we want to have, but we will not necessarily achieve it. So later on, so we record the actual weight here. And later on, we can do the variance analysis. So we can see how much the weight of the actual product deviates from the target. So any questions? So you see that it's basically a fairly systematic way of describing different types of policies and how you introduce them. And completely declarative. So what do we have here? Well, we have a compromise pattern, right? So we have only one object class at the operational level, right? And we have two different types at the policy level. One describes the item category, and the other one describes the quality category, right? And then our policy is described by the association class. So the mechanism is association class. It means that an attribute in the relationship table that actually relates the item category to the quality category, right, describes this policy, right? Now, in this case, okay, this is the price. This is the derived attribute, right? So again, this is knowledge-intensive description, right? If the price is defined, then that's it. There is really nothing to check or verify. It has to be that price, right? So again, for that reason, this price is a derived attribute. So this is one example, right? This is an example of a validation rule type. So what is this? So in a conventional way, you can see, okay, this is a shipment policy table. This is actually an enterprise policy, again, which is described at the policy level. And it is described between the type of customers and the type of transportation, right? And it tells, for example, that for internet customers overseas, international customers, the only allowable type of transportation is either plane or boat, right? So we cannot send it by train, we cannot send it by truck. Right? I don't know if you know, but in the early days when Google Maps just became available and you could create routes from different places, people discovered that, say, if you create a route from New York City to London, then Google Maps will do the routing. They will take you somewhere to one of the ports in New England. And they say that from here you swim to that part in the United Kingdom, and then they continued with the routing. So, well, obviously here you send it either by the plane or by the boat. By the way, it's not made up. I've done that. I experimented with it. I've seen it with my own eyes. So those guys had a sense of humor. Anyway, so how is it expressed? Well, here the pattern is mirror. Why? Because we have customers and we have shipments, right? a customer is an agent, a shipment is an event, right? So we have operational level entities, classes. And there are policy level, right? Customer type and transportation type. And this is a mirror pattern. And here, this is just a many-to-many relationship. So the mechanism is association, but what is implemented is a validation rule. So basically, this many-to-many table will contain only the pairs of customer type and transportation type, which defines the allowable modes of delivery. Okay? So this is how this stuff is implemented. Again, this is fairly straightforward, right? Any questions about this? Okay. So here we are dealing with a hybrid, right? And the mechanism again, the association. So this many-to-many table. But here we are dealing with a hybrid pattern. Why? Because there are very few carriers. When you're talking about carriers, that we are talking about what? UPS, right? We are talking FedEx. Maybe we are talking about DHL, right? I don't know if there is any other viable carrier that you can use. So there is absolutely no reason to have a policy level class for the carriers. So that's why we're dealing with a hybrid pattern where the policy is defined through the association between an operation level and the policy level object. So for different shipment types, we define acceptable carriers, right? For example, if we are talking about ground shipment, right? We can say that the acceptable carrier is UPS. Right? If we are talking about plane shipments, right, then the acceptable carrier can be FedEx and DHL. Right? So, and then when a particular shipment is assigned to a carrier, by the way, this is a participation type relation. You remember that the relationship between agents and events are control participation type relationships. So when it's an external agent, so it's participation. So when a particular shipment is assigned to a carrier, then the policy enforcer will check that actually that this carrier is approved for that shipment type. Okay? Again, fairly straightforward. Another example of a validation rule, but now the pattern is a root. So when there are two different categories, one typification and one grouping, right, at the policy level. So and here the grouping is actually projects. And typification is really employee types. For example, I don't know, you can go by their seniority. If it's a consultant organization, you can have regular consultants, you can have senior consultants, you can have managers, right? And it may be that for a particular project team, it's a high value project, you don't allow regular consultants. It has to start with senior consultants, or whatever, right? So therefore, a particular employee can be assigned to a particular project team only if this type of employee is approved for that project team. Okay? So the policy is expressed here, right? And type of employee is a type of employee. So when the grouping is implemented, you check that the grouping is in compliance with the policy. Questions? Okay, target descriptions. This is probably one of the more involved parts here. So here we are dealing with the mirror pattern. and the policy is expressed by means of the attributes of an association. So it's an association class. So what is the policy here? Well, the policy here is basically a standard for production, which is expressed by the bill of material, BOM, you may hear it. So a bill of material is a complete description of all the components of your product. All the raw materials, all the sub-assemblies, all the intermediate products that go into production of a single product. Okay? And this is, by the way, pretty much every manufacturing enterprise needs this. So they need this description. This is basically your policy of what that particular final product, finished product is. Okay? And so this is the type of finished products. So for example, I don't know, a kitchen table, right? A finished product. And there are different types of raw materials. And here we have a many-to-many relationship, right? Between raw materials and finished products. And this many-to-many relationship describes the bill of material, right? So it basically, because the same raw material can be in many different finished goods, and a particular finished good can typically will use many different raw materials. And here, say the attributes describe the quantity and the cost, right? And what is interesting here is that so the cost is not something which can be fixed. If for no other reason than say the cost of that raw material fluctuates. Right? So it's basically more like a target that we want to achieve. So here, this is what is desirable. This is here what is achieved, what has been achieved, right? So we can see, calculate the variances between the expected cost of our bill of material and the actual cost for a particular finished product. But a part of, so this relationship, okay, when we have here with these different raw materials, so it also depends on the quantities, right? So the quantities are specified there, but they're implemented through the relationship down there. So this is a more involved example. Now, bill of material can be viewed as a standard. Something very similar happens with a budget. A budget is not a standard. It can be viewed as a corporate goal, right? Now here, again, the pattern is simple, even simpler than that, it's a basic pattern. The mechanism is also, it's just the attribute. Okay? But the way it is implemented, we use the target descriptions, because this is not which can be inherited. And this is not what defines any kind of acceptable value. So this is what we want, right? So this is what we want. And this is what we actually have, right? By the way, you see that what they put in the budget, this is actually not necessary. This is a derived attribute. So why is it a derived attribute? Well, because it is a sum of these, guys. So for example, when we are dealing with sales, sales are typically grouped by type, right? So, and usually there is a budget that we want to sell certain amounts by a certain date, right? So here we can specify the time periods and we can specify the budgeted amounts. So what is interesting about this particular example is that the association between the operational level and the policy level is implicit. And again, this can happen. So this is the significance of the dotted line. In what sense it is implicit? Well, when you record a sales event, so you have this entity, which is the operational level entity, which is an event entity, right? Sales. You have the policy level entity, sales budget, right? Which specifies budgets for different time periods. So in a way, there is this grouping association, right? Between sales events and sales budgets, but it is implicit. You don't really have to establish it in the database because it can be calculated based on the actual date of sale and the definition of the period in the sales budget. Okay? So this time period, as it is defined here, the most common way to define a time period is by specifying the start date and the end date, right? So therefore, when you have the actual date of sale, you know if this sale belongs to this period, if its date is within the interval. After the start date, but before the end date. Okay? So this grouping doesn't even have to be established explicitly. It is defined implicitly at the policy level, right? So you define the budget amount, and then you can just determine which actual events are in this group, calculate the total of the amounts and compare with the budget. So do this discrepancy analysis between the actual and the budget. Questions? Okay, so there are two patterns here. So this is a broken down budget definition. So what happens if your sales budget is broken down, say by the salesperson, right? So it's typical to have the budgets defined not only by the period, but for the individual salesperson, okay? Now here, what is interesting here, you also have this budget for the different types of finished goods. So you want to sell a certain number of finished goods in a certain period, and you also have those budgets allocated for the person. So here you actually, again, this is as you see there, we are getting close to the end of the paper, so the results are getting more complex. So things start piling up. So the policy definitions are defined by the associations and by the attributes, right? So, and there's still target descriptions because we cannot really achieve we cannot guarantee that we achieve this budget. So we have this budget quantity. Right? This is the mirror pattern. Again, the only difference that the grouping of sales by the time period is implicit. Okay? And there is also this hybrid pattern where salespeople are actually assigned to participate in particular sales budgets. Okay? So this, it's basically like sales teams, if you think about it. Okay? So this is a grouping association which tells you who participates in what sales team. These are budgeted stock flows, right? So there is this budgeted quantity. So this is the actual that happened, right? So you can calculate, you can add up what actually happened. This is a derived attribute again, so the actual quantity, and you can calculate the discrepancies. So different ways of using target descriptions. So basically target descriptions, the examples are shown for technical specifications like bill of material, right? Target descriptions, and for corporate goals like budgets. Okay, just to wrap up. So we use different types of policies. We can have knowledge-intensive descriptions where something is stated at the policy level and is just inherited down to the operational level, right? We can have validation rules which state the constraints at the policy level, and those constraints are enforced at the operational level, right? Like, so being of a particular type. And we also have these target descriptions which tell us that things should be about this, but they may not necessarily be like this. And then we actually can calculate the discrepancies and decide the discrepancies. So it's a very flexible way to express corporate policies. Okay? And I think that it was a major advancement in the development of the REA model, because it really extended it to this very important topic. Not only to describe in our enterprise system what has actually happened, but also to declare what is supposed to happen. Right? Any questions? Okay, then I think I'm done.